Everyone, whatever part of the world where you are at. It's my pleasure to be your facilitator today. Today, we are talking about create production compute targets and deploy models. Create production compute targets and deploy models. My name is Gabriel Onifade. I'm a Microsoft certified trainer, a certified data engineer, data scientist, and a systems engineer. Our sponsors are displayed on the screen. Without further ado, let's get started. Yes, this is week 8. And my job today is very easy, very simple. If I can just describe what is on the screen now, I think my job is done. I then go to the question and answer sessions, and we all can be happy that we have done justice to this. Now, the operations that you perform on the Azure, in the Azure machine learning, they are called the experiments or the machine learning experiments. So this screen simply display our experiments, the things that are needed. And what we are really looking at today is more basically like data science for the computer village people, or data science for game lovers. If you were part of my session like 3 weeks ago on data engineering, we spoke about batch processing on the data fabrics and data factory and Databricks. And that's I try to describe as data science for market people. Just to tell you that there is another platform that you can use to make your ETL a more advanced ETL operations, and then you can add it back, the output, as an input into your traditional ETL you are using. So the data factory connected to the Databricks gives you more capability to do more advanced features, to take advantage of more data that affects your business. Unstructured data, more advanced structured data, videos, blobs, heat sensor, whatever. Those other things, stakeholders, those other factors that comes together to affect your business. Those ones you can connect to the Databricks. Those data that can only be stored on the data lake can be connected with the workspace on Databricks to the data factory. And your data factory is just like your traditional data warehouse, but in the cloud. So that helps you to take advantage of more features that can support your business, and you can still continue the way you are doing your work, but you are adding more capability with the provisions of Azure. So today I said is data science for market people, data science for computer village people, data science for game lovers. If all you can do is get your computer, connect your applications, and play, then you are good. That is basically, I would say, a requirement for this class. But then there is more to it. And then let's get deeper. Like I said, I have here just 9 steps, starting with our computer. Your data that you want to get an insight, you want to get more from, or your data that you want to use to create a model for more feature data. You get the snapshot uploaded into your pipeline. So your pipeline are being orchestrated here. that is in your machine learning workspace. So we can see here that our machine learning workspace is like one-stop shop to oversee all our machine learning activities. And then it can also enable us to do reuse of that same space. So we have our workspace, and then our Docker image that can be created for us, okay? Because we can have some curated environment created for us, because we need our Docker image to create an environment to run our experiment. And that goes to our compute target. Our compute target connects to our data store. And then from there, we can have the log output on how our data is performing. And then we can have our data output that comes back to our computer. That computer can be your traditional data warehouse. It could be a web service for your customers to consume. It could be a collaborative space for other team members to take advantage of, or where you can continue to add more data to improve on your experiments. So from our topic, we are creating our compute targets, okay? And then we are deploying our model. That is what we deploy the activities from our pipeline. What are the activities? The activities, they are the output, the performance of the things you do on your data. When you combine those activities on your data, like cleansing the data, reprocessing the data, splitting the data into training data set, and then the target data set, then those activities, you can even do scoring of the data and then evaluating the data. When you put all those activities together, running your regression analysis and models and algorithm on the data, when you put all those activities together, you have your pipeline. And those pipeline can make up your workflow. And those workflow, when you submit them, they becomes your model that you can publish. The moment you publish the model, then you can consume the models by changing parameters like, from your customers or from your team. And that can help you to achieve your purpose. So basically, like I said, all other things I'm going to discuss will be just around this image that I've shared on the screen. I hope we can maybe probably come back to it and then to revisit it so we can understand better. So basically, we are creating our compute target, and then we are running our pipeline operations on the compute target, and then the outcome, when we deploy it, that becomes our model that we can publish and share with our customers and then with our colleagues. Like I said, what we want to do today is very simple. First, we want to connect to our Azure Machine Learning workspace, create the Azure Machine Learning data set, create reusable Azure Machine Learning components, create, validate, and run Azure Machine Learning pipelines. Then we deploy that, the newly trained model, as an endpoint. That is what we use to connect to our model or to make it available to others. And then we can call the Azure Machine Learning endpoint for inferencing. That inference is now what we can use as a reference to train future data and then to also share with our customers. And then the parameters can be changing, but the inference actually creates a representation of our experiments. Like I said, those operations we carried out, our machine learning, they make up our experiments. So that inference represents the total activities of the pipeline and the workflow that we have created to represent, to make up the model. That becomes an inference that can take some other new data sets and it can give us the desired results. For starters, what we need to do is to create your workspace. Okay, when you have a workspace, then we can connect to that workspace. I mentioned the workspace is a centralized place to view, to manage our components, our artifacts, and then to create that we created during the Azure machine learning operations or the experiments. So what we need to do, we connect to the workspace. That workspace is where we work. And then on that workspace, we create our compute resources, which in this case is our compute target. It could be compute instance, maybe just one single computer, and it could also be a compute cluster to perform our pipeline operations. Okay, the cluster consists of more than one computer that we can use even for real-time operations of our machine learning models. So create the cloud-based compute instance. That's what we are doing. Then we create the cloud-based compute cluster. Now, when we talk about cloud, for market people, what is a cloud? Cloud is just like another person's computer. However, it is a more powerful environment where you can do more and get more for your business purposes. Let's try to go through some fundamental understanding of what we need to do, and then we dig deeper into it. So, run context for our experiment. Where do we run the experiment? I said the operations we perform, they make up our experiment. So where do we do it? We do it on the compute target, as I've explained earlier. And that compute target, as we saw in the initial image I shared with you, we have the Docker image. That is creating an environment. So in that compute target, we can have a container. Inside that container, there's another environment to run for that activities to run. And then we can have more than one environment in our compute target, everything to make up our pipeline activities. So the environment is usually, but not always, a container. So like we can see, and then the container or the environment is hosted in a compute target. Again, our compute options for the experiment to run, it could be a local computer, it could be in the cloud, it could be an attached compute instance or a data store like the HD inside Databricks or whatever we want to work with. So creating a compute cluster, we can create it in the Azure portal, and then we can also do that with the SDK. This is an example of what we do. If time permits, we look at the option for using the SDK, but hopefully can go into the Azure portal and try to practice some of these activities. Like in the other video I did 3 weeks ago, we mentioned some fundamental things, some jargons that we get used to. Your data store. Your data store is like your online database. So call it Azure Data Lake, SQL, Databricks. It could even be the built-in into your system. So that is our data store, like the online database where our data can be stored for the operations. Then there are considerations that we need to go through for our data store. Configure the blob storage to perform the type of the experiment that we need. And then we also know that the package file format performs better than the table structure that we have. Then we can also, when you create your workspace, there are default data store, and then you can change it. If you are working on the team, you can set it just like we can see on the display. And we also need to know our data can be different type. It could be blob file, it could be data table, queue, or data lake file where we have the package file format. Hope we can discuss that better. Then also, we mentioned in the past that your types of data could be blob data, and that blob data could be append, we block, that is for your video or audio files. We append, that is, for log files and other operations, then it could be page files. That is your virtual machine disk that can attach as your file. Okay, so then our files. So we have blobs. Like I mentioned, the blob could be block, we append, it could be page. Okay, then we have files format, and that we also have the table format as well, and the queue format. So to get our data into our cloud to a data store, these are the tools we can use. We can do that with our traditional SSIS, or easy copy as well storage, or some other means. PowerShell also can be used. Then what is data set? That is our data, okay? And your data could be tabular data or file data. And based on the usage of the data, you can have different versions of the same data. Now, this data, we mentioned earlier that Packard file format is more optimized. So this data set can be taken through some environment like the Panda environment. That's the flavor of Python, where this data can be converted into data frames. And that is an example of our Packard data format that is more optimal. So data frame, if it's tabular, distributed, SQL, that is the better format for performing our machine learning operations. Then this data can be data store. In the data store can be connected to our maybe Power BI, some other way to see the data. Even during the experiments, you can see the output of how the data are performing. So our data format, the Packard Square query, can be used, to query directly on our data in the various formats. And all these things can take place even in the Hadoop file system. The Hadoop file system is a flavor of the Azure Data Lake. It uses the Hadoop file system, which is a flavor of the Apache Spark. The Apache Spark is an open source. The HD Insight is the Microsoft Azure version of the managed version of that Apache Spark, and that works well on our file system. So another thing we use is the Azure Synapse to perform more advanced operations on the data, as you can see on the screen. Then we mentioned our Azure Databricks, can have a workspace to work on more advanced data in different formats be connected. So, and then we have different teams can also work on our data lake, the data engineer, data scientist, business analyst. All these things give us more capability to do more with our data. Also, the data factory I mentioned earlier can be your data warehouse, but in the cloud for more advanced operations that can be connected to feedback into your traditional warehouse. Then Databricks also, we see the various way we can work with it as well. So we can integrate data with the Azure Data Factory, and all this data in the various formats, either structured or unstructured, all these things can be brought together to form our pipeline, and then we can create our data set, and this data set can be converted into data frame for more advanced machine learning operations. So who are the stakeholders? What are the stakeholders for our data? We have our data source, our data storage is in the cloud. Your data store can be IoT, maybe something you are picking from a monitoring CCTV camera, or from a video streaming, or from an event, or from your warehouse, wherever. Your data store can be any format of the data that we have described earlier. And then it could be real-time message ingestion of the data from IoT Hub. And then what can we do? We can do batch processing on the data. We can do machine learning on the data. We can do process streaming. So like I mentioned, like 3 weeks ago, we discussed the batch processing operations. Today, we are talking about the machine learning operations. And I guess in the future, we can also look at the streaming processes as well. So all these things, we do our data analysis on all these stores. And then when we analyze the data, perform after our experiments, then we can have our data analytics and reporting Of course, that can help us to achieve continuous integration, continuous delivery from our data set. So if you say, I'm a .NET developer, I'm a Python developer, I'm a Java developer, yes, we need all those things to work on our data, and then that get connected to our pipeline. Our pipeline will ensure with some DevOps operation and ML, machine learning operations, we ensure continuous integration of the outputs and continuous delivery of the data. And then we can have some pipeline operations to work in the Power BI deployment for our reporting and for the purpose of making the best use of our data. And all those things can be displayed on the Power BI dashboard. Now, again, let's look at our data. What is the modern data strategy? The modern data strategy is telling us that our data is not just the traditional data that we are used to. We have big data processing, relational database, non-relational database, machine learning, data warehousing, log analytics, whatever format is going to take. So these are the various ways we are looking at our data in this modern system, and then everything can actually be stored on the data lake, and the data lake, you need somebody to monitor it, and that's the governor. So the data lake, we have the data governance to coordinate and to orchestrate and to tell us how the various operations that we can perform on this data to get the best for our system. So if you have been hearing so many jargons about data science, now this is just how they come together. Okay, it could be relational database. Is it Oracle, SQL Server, Postgre, Mongo? That's relational database. Non-relational could be MongoDB, Cassandra, Redis. Then data warehouse could be Oracle, Microsoft SQL, Hadoop data, Spark, Pig. Okay, those are the Hadoop data. What we can use to work with our Hadoop data. Then for operational analytics, you have something about Elasticsearch, Kibana, Logstash. So, and then you'll be hearing about Kafka. You know, that's for real-time analytics. Then machine learning, TensorFlow, PyTorch. Those are the things there. And then the scikit-learn that we're going to use today is also used part of what machine learning. So, if those things have been confusing you, I want to believe that with this single demonstration and the preview I've done, we'll be able to have a better, become more comfortable with what we call data science and what we are trying to do. And so you can also decide what role do you want to perform. You could be an analyst, database administrator, data engineer, data scientist, and then we have the various categories of this data. Could be descriptive, diagnostic, and then predictive, whatever. So this should be able to help us. But then for us to really do better, that is why we've brought to us this Microsoft challenge. And I want to advise you, let us take advantage of this. This challenge will be ending in about 8 days from now. So let's check some of these. Some of them maybe like 30 hours or maybe 60 hours. You can complete the challenge. Some even 5 hours can complete this challenge. So we may not be able to do so much now. You want to do lab practical, please take advantage of this challenge, and you can really do more to yourself. Now, to get started, what we need is your Azure data subscription. So go to azureportal.com, you log in there, or you can create a new account. So after that, you need a subscription. Okay, so you can have a free subscription, or maybe a student subscription to start with, or you can have a paid subscription for you to do better. And some of the things you will see is what I've just displayed on the screen. Now, for your machine learning, just go to search for machine learning, and then you click on create. When you click on create, you need to take note, then you specify your subscription you are using, give a name for your resource group, and then just try to look at some of these images, just telling you exactly what you are going to see. And then for your machine learning, 3 things are created for us: your storage account, your keywords, and your application insight. So take note of that in case of your examination. After you have done that, specify to create machine learning, you launch your studio, and then that gives you your workspace where you can work with all the data. When we get in there, the first thing we may want to do is to create our computer, the compute instance for our machine learning operations. So on the left pane, you will see compute, click on compute, and then create a new compute instance operation. You can specify, as we can see on the screen, just the cheapest one is the DS11V2 that we can use for our operations. Moment you are done, then your compute is already ready. Now, there are things you can also create. You can create your compute cluster, like I mentioned earlier, for your pipeline operations and the machine learning experiment. You can create inference cluster that we can now use for our deployment for others to get connected and for future data training. We can also create attached compute that we saw. You can attach Databricks or other sources to our data. So the configuration setting is also displayed on the screen. So all these things are the kind of things you see when you are really working on the experiment yourself. And the moment you are done with that, you go to Notebook, okay? Still on the left pane of that, your workspace, and then you can make sure you connect to your compute instance that you have created, and then you click on the terminal. When you click on the terminal, then you can clone. There are some sample experiments you can connect to. You can also clone some activities that Microsoft has made available for you, and this can help us to continue, and you can continue from there and you can learn more. So if you clone that, in fact, most of the things we need to do today, the samples are there. Just connect to it, follow the instructions, and then you can run your experiment. So we have mentioned how to create our compute target, and then with this experiment, you can also look at how to work on that with the SDK, and then I think you can create our compute instance, you can create our pipeline, and then you can deploy them. And I think we are done. So when you create your compute cluster, the designer is created for you. You can rename it to use for your own experiment. Now, Machine Learning Designer is like a drag and drop platform where you can, just like what you do in your data warehouse ETL operations, to work on your data for your data preparation, data training, and then evaluation and scoring. And then you can now deploy from there to create your inference. And from the inference, you can deploy your model that can be used for future experiments and usage. So data store, all those things can be created. So next, you go to data pane. Under the asset there, you create your data. So I mentioned your data store is your online storage. You can create your data sets. You can connect a link service to it, create pipeline, create models and endpoints. All these things you can always do with your workspace. So creating data set, you go to data, click on create, and you have your data set created. These are some of the screenshots of what the experiment and the activities will look like. Now, create data set. Now, your data set, the same thing, that same operation. And after creating your data store, you can create your data set. You can download, you can just search for some, maybe like a diabetes data set that we use in this particular experiment. And then you can connect it through a link for creating your data set. And we can see that can be used in this experiment. So when you have your data store, you have your data set, you can actually use this for automated machine learning experiments. These are like pre-baked algorithm that can be used to perform the experiment. So the Azure is a very rich resources that can help you to get started and to use all these things for your experiment. So if you can follow through some of the steps in this screenshot, that will really help you to complete your machine learning experiment. And then you can see how your model is performing. That is also displayed on the screen. And then you can deploy that and now use it for some future data testing. So you can deploy a predictive model. Now, when you deploy it, you need a REST endpoint. You will say, I know HTML or something. You can now share that REST endpoint like HTML link or webhook for your customers or your other team to connect with the performance of your model. They can bring in their data. But for security purpose, you have to share with them the security key, share with them the link for the endpoint, and then the security key also that they can add into their code to get connected to your resources. Now, after the deployment, you can test, the deploy service, like we have also seen in this experiment. If you can follow through the screenshot, I want to believe that you'll be able to do justice to getting a hook of creating the compute instance, testing, deploying creating a pipeline, and then testing it, and then deploying the service. After you have done with that, please don't keep those things in your running the computer running. You can delete the endpoint, then you stop also the compute instance so that you don't incur costs and you don't have surprises as well. And so if you are not using them in the future, you can simply delete them. So designing your pipeline is very simple. Like I said, they are drag and drop operations. By the left-hand side of that, your designer, you will see the components there. Bring in your data, and then normalize the data. Then there are modules. All those things, activities together, they form your pipeline. Actually, we've done justice to what we need to discuss today, but I will just be saying some other things to get us more comfortable with that. And this is probably what we even do maybe like next week. So these are some of the things to do more on how do you work with your designer to create a pipeline and to deploy inference model. You have done, you create an inference, and they can connect to it for future experiments. So this screenshot also shows you how you can get started creating your design pipeline, and then you can also create your inference and deploy your inference. So your data transformation components, you had all those things there. Then you train your model. This is, and then when you train, you submit. When you submit, then you can create an inference of the pipeline. And then when you create an inference of the pipeline, then you can also submit that as well. And then you can deploy it for your customers to use and for others to also take advantage of. You can test the web service. If you are done with that, also do a cleanup. I want to believe with this few illustration, you are able to actually get started. This is essential of getting used to the machine learning, creating a compute instance, and then deploying your model. So thank you. Thank you for your time. If you have questions, you can please post in the chat session. You can connect with me on LinkedIn. You can send me a message. We can discuss further how to get started and how to continue. Again, I want to say thank you to our sponsors. Thank you for your time. See you some other time. Thank you.